Hello, ladies, gentlemen, and small fur creatures from Alpha Centauri. Welcome to mission control of the Garden Space Agency. Today we're gonna launch WaterFeeler2. That's the new and improved version of the original WaterFeeler probe. I should open the folders. Yeah, it's much more stuff in the same box. Basically, there's a camera, Raspberry Pi, the other sensors we previously had. We now got a porch with an additional antenna for radio frequency interference, like 50 Hertz detection. We got a sky mirror that mostly shows us the solar panel. The porch plate, the nameplate, that's not the newest photo, I'm afraid. There's also an LED to attract insects, in theory, and that's a sample image of how a panorama would look like. But the Raspberry Pi takes a lot of power, so we can only run it for a short time at any given day, depending on sunlight and whatever. I already locked the probe outside, but it's still off, and that means I have to turn it on. I have to go outside for a second. And then we should get the first data, I hope. Give me a minute. I might need to restart the modem and controller. Do I? No. Okay, it's on, but in power save mode. Let's. Okay. So it's powered on. And we got data! Yay! So it's about 22 degrees outside. Those sensors are not very accurate. There might be a degree off between them, but I think it's about 21 degrees, something like that. It's not raining, obviously. And from the voltage, this is also not very a good measurement because the Arduino has a rather how can I put it, bad way of referencing the voltages when voltages get low, but I think that should be pretty much what we got. Okay, we get data incoming. This is the this is my messaging network. We're currently, I think we can check, read out the probe config 4 and 5. Yes, we are relaying via DGN2. That's the Deep Garden network, which works quite nice and is updating. I want to check out the camera, but as I said, it uses a ton of power, so we can only do some basic images and transfer them down in low resolution. But for that I need to what is it? Global, I think 30 is the one we're looking for. Power save enabled off. Okay, Perl set conf register 30 disabled. So that should disable power save. We don't have auto power save enabled. This is disabled. Okay, it's 0. That's good. Then we could power on the camera. Set conf 24.1. No, that's not good. That was the wrong command. What was 24 supposed to be? Damn it, I'm ruining everything. 24.0, okay. Right. Send command 24 on. That should power that on, and in like 30 seconds or so the Arduino is going to reboot, because that's what Arduinos do if you connect USB. So didn't reboot. That's not good. Okay. Yeah, now it did. And the battery voltage dropped because we're using much more power. First we take, I should also open a new file. That's 1924 at 944 single frame servo 1100. I think that's okay. Okay. We got confirmation that it does that. It takes about a minute to take an image and convert it into a file we can use. Okay, we're here. Alright, it's a bit faster because I don't do image stacking. Okay. Take panorama 0002. That takes about 5 minutes. I need this because I don't have good timestamps on the probe, so I need to manually do this locally. Right. I really don't have any clue what the panorama is gonna see. For the simple reason that it has a bit of a strange point of view, and that's on the table without the solar panels mounted, so we'll have to see. I can't download the full resolution because that takes ages and ages, and I don't want to risk the battery running out even though we got the sun shining on the probe. Yeah, I have to wait and wait and wait, because as long as it does that, we can't do anything else, I'm afraid. Yeah, I can tell you a bit about the software. Through the Raspberry Pi, it takes quite a few images for the panorama and stacks them, or not stack, merges them with the Huggin panorama software on the probe. That enables me to basically I don't have to pull multiple images and then merge them here, because that would give me many duplicate pixels and stuff, and that's just, I don't have the bandwidth. Today we're only going to download very low resolution images, because even that takes quite a few minutes. Yeah, we'll see. I think we still have 2 or 3 minutes to wait. Raspberry Pi is quite slow, and taking the images is quite slow as well. I'm also not exactly sure how well we can see the sky, because at the last minute I had to mount the solar panel a bit differently, and it might obscure some view of the sky, but at least we should get good location shoot where we are, and see if everything works so far. I think it's a minute to go. It currently doesn't show on here when the probe is finished, or the camera is finished, I'm afraid. Okay, it's finished because I can see it here. It's send ID CD. That's the internal encoding for ID 35. But I'm also not gonna download the how can I put it, the uncompressed images today, because I want to shut the Raspberry Pi back down and charge the battery to full. But we're gonna download the thumbnail first. Right. And as you can see, it's quite slow. We only have to download 8,766 bytes, and that's only the thumbnail for the single frame image. We can only transfer 16 bytes per packet. The packet itself is 30 bytes big, but there's a lot of routing information and checksums and other overheads. So we got 16 bytes left. So as with the first WaterFeeler, I'm probably going to be able to improve the speed quite a lot for downloading those images, but I'm not yet there. I have to test a lot of things, and I want to do gradual improvements, cut down on the delay times, improve the ground control software, that sort of stuff. At the moment we are requesting every single packet from mission control, but I do have the option of telling the probe, okay, send me the next whatever, how many bytes, and it generates all the packets. But I still have to test that software and debug it further, and this is the safe version, the version that actually works and works reliably. That's the point. The probe software should have no problem whatsoever. It's just the ground control software that needs improvement, and the radio network needs fine-tuning. Okay, ignore that error message, that's okay. And we also want to download the thumbnail for the panorama, and we're probably going to get a slightly higher resolution of those images as well. There's probably not much to see at the moment. Yeah, and it's on its side as it should be. But yeah, we have, that's the nameplate, that's the RFI antenna, that's the sky mirror or the solar panel mirror. It points to a solar panel. Yeah. Well, the solar panel and a bit of the sky. That's the test solar cell, and that's a test for how well hot glue holds up. And that's the cable to the LED that should attract insects during the night. We'll have to see. Right, safe. Currently the sun is shining on the solar panel, so we shouldn't run out of power. But for the next few days, the forecast says it's gonna be cloudy, so I want to save as much power as possible. Yeah. Come on. And the whole network can only handle one packet at a time, otherwise there are collisions. That's why we sometimes get timeouts, because other stuff is sending as well. I could turn it off, but I'm not going to. we run those experiments. So, and that's the wrong name. Okay, yeah. But we run those experiments later after we power down the Raspberry Pi. I could. Yeah, come on, come on, come on. Yeah, that's typical IT and space missions. You just have to wait sometimes. I mean, we can open it. It's just not gonna be the full image as of yet. Yes, maybe we can see sky, maybe not. That looks like plant life. Reload. Okay. 2-second timeout. We can. Yeah, I can't set it any lower. Why is it getting slower? Yeah, and before downloading the could actually DGN2. Yeah, I'm not gonna see the configuration as long as this scrolls by. So Yes, this is, come on, space. The final waiting room. Nearly there. Okay, we here. I want to come on. Maybe let's see. Let's see if we change you. Yeah. Okay, maybe we don't need DGN2. We can send direct to my living room. We'll try that. Okay. That's the configuration for the Arduino. And I want to see the delays. 24 is origin and 24 and 2. That doesn't seem right. Y. Okay. Okay. And 26. Okay. In theory, PanCam okay, read the configuration of the PanCam. What? Was that the 16? Okay. That is also very high. Zero. Let's say 100. Download. Let's see if this, and download it to test PNG. I think we just increased the speed quite a bit. Okay, that's good. Okay. Okay, now we're cooking. And I can probably optimize that quite a bit more actually, but not today. Let's just see if this is still a valid file. No? Because I edited the one by turning. Okay. That's the panorama we got. Yeah, that's the thumbnail image. So that's basically the porch and looking up through the solar panel. that's a bit of the sky. What we could do is what's the command number? 33. I want to see percent command 33. Okay, that did it. And then we can download download lstxt to lstxt. That's always the remote and the local file. Come on. Okay. And how big is the small? Okay, what we want to download is the medium resolution single image. And then the small resolution thingamajig panorama. Maybe even the no, the small resolution, yes. That's that is going to take a while. But it's the medium resolution is actually quite quite good. I mean, it's only 300 or 298 by 224 pixels, but it's better than nothing, and it shows quite a bit of detail. We can I think that thing is even reloading as it gets more data. That's interesting. Didn't know that. Yeah. Bum 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 bum. Please wait. Yeah, we get quite a lot of radio interference in my area, so yeah. So we get packets lost to radio interference, then other stuff sending on the network. It's quite fine for status frames and like update this every minute or so. Transferring files is a bit of a well, it's not optimized for that, just to put it mildly, but it works. The real concern is that this is coming from the Raspberry Pi, so it uses quite a lot of power from my very limited amount of power I have. And the next probe is probably going to I have to experiment it, but like an SD card that could either be connected to the Raspberry Pi or to the Arduino, so I could how can I put it? The Raspberry Pi takes the science data, the images, whatever, writes it to the SD card, powers down, and then the Arduino connects to the SD card and sends it overnight, because the Arduino uses so much less power to do it that it basically influences the amount of science I can do for the size of solar panel I have. I mean, I could do everything with the Raspberry Pi, but then I need like 500 euros of solar panel and batteries or something. Yeah, I think. But even if you compare this, let's resize it to about the same size. You can see it's already much more detail. But the thumbnail is a very good way of getting a basic overview if the picture even worked. So if I have the right camera settings and whatever, because yeah, I can upload new camera settings as well, so that's a bonus. And the idea is I might even be able to image the stars at night, and I'm certainly gonna try to turn on the LED that's under the nameplate, wait a few minutes, and then take a series of images to see if we can detect insects. But that's not gonna happen today. That's gonna... Oh, we are running low on power, I think. Okay, so no panorama for now. I just hope I can download this single image before my power runs out. We're halfway there, but yeah, I mean, it's morning, but I have lots of trees around, and the solar panel might be in the shadow at the moment, so come on. Come on, come on, come on. Yeah, that's a drop of hot glue that's standing up. I want to see if it warps over time, if it falls down, to see how stable it is in outdoor applications. That should give me a good information about how well the sealing of the electronics box is holding up. I could reduce the timeouts by disabling all the status frames and science frames from WaterFeeler2, but that might not be the smartest move. Okay, the external sensor reads 27 and the internal reads 24. That sounds a bit high. Well, maybe close to the ground without much wind, yeah. And the sun is shining directly on the probe or not, I'm not sure. The voltages is getting low. Come on, transfer. What I could do, just to be on the safe side, no, don't need that, don't need that. Okay, and then I say no. Zero if we find zero and argv 0 equals then is 1. So we can basically send that in the blind. Okay. Make that a new function. Awake, return, and say, okay, sub send keep awake. If then we don't need that, right? Okay, if force flag, then we just send keep awake and exit. Otherwise it would wait for power on thingamajig. Minus force. And then config 31, go to enable power save mode, but keep the probe awake. We got the image, okay. And for now, we are going to send the shutdown command. Send command 40. Wait 30 seconds or so before turn off the Raspberry Pi. So if something happens, we have power save enabled. That means the probe will only wake up currently every somewhat 80-90 seconds, send some data and then go back to sleep. Normally we use 60 milliamps when the Raspberry Pi is off. when we use power save, we mostly use about 30 milliamps because we power down the radio, power down the Arduino. We only have the voltage regulators running. Okay, we can turn it off. And yeah, we got okay, we got vegetation. We got a blue sky. No rain. So far, it looks good. Save, yes. Voltages are coming up because now we got much less load on the thing. That isn't right. We don't have those and those. Okay. Start. What do we need? We tried it for we tried a 1K resistor, 0 delay, initial checkout, 10K no delay. Uh, 1K no delay. Okay, we want to run a soil capacity measurement like we did on the old probe. Send command, and then we want to run command 14 to download it. Command 14. Okay, we got a measurement. This looks similar to what we had on the previous probe. Okay. And do the same with the 470 ohm pull down. That should go straight down. Right, okay. We have a measurable capacity. We want to run start RFI series. What does that mean? Okay, need okay. Initial RFI check out no delay. I want to see if we can measure any power line interference. Okay. still have to fine-tune the all the instruments, but we want to send command 27. 27. No, what am I doing? Send command 27. What? Okay. Interesting. Okay, so far I got nothing. That will take a while, 30 seconds I think. Okay, and download that. It's basically measuring the capacity of the antenna, maybe. That's a standard command. I didn't have to modify the program. Okay. We'll send the probe to power save mode again. But yeah, it seems to work. Didn't get a good RFI measurement, but science says if I can't find it, then maybe there isn't power line interference, which might be a good thing, but I'll still include that measurement in all future probes. It could still be useful, and we might be able to use it to detect lightning or something like that. But let's go to power save. And the probe should go to power save, I hope. Shutdown for power save. Okay, right? Okay. We do have this in the can, right? it should now wake up periodically and report on the battery voltage, and that should go up over time. It's still before noon, so we should accumulate a bit of power. I hope, maybe, we'll see. But for now, I'm gonna conclude the live stream. I might stream during the evening again, depending on how much power we have and stuff like that. I might be able to download a higher resolution thingamajig, higher resolution panorama, but I'll have to see how this is going with the power. Okay, bye for now, and thanks for watching.